So either way would be our answer. You're going to see it written both ways, okay? Some people like to actually extend their limits all the way up and down. So you can see this is the furthest to the left and the right. This would be the lowest and the highest. So it kind of creates like a box. All right, so now we're going to list the domain and range from this graph down here, okay? So we need to figure out domain, smallest to largest, looking at our x-axis, and then range, lowest to highest or smallest to largest, looking at our y-axis. So we'll start with our domain. Smallest, your smallest numbers are all the way the left. The further to the left you go, the smaller the numbers get. So my function, the furthest to the left I have a point would be right here, okay? And this is at -3 on my x-axis. And then the furthest to the right that I'm going to have a point, so the largest x value that I'm going to have on my graph or on my function is over here, which is at 1. Okay, so my domain runs from -3 to 1. -3 has an open circle, which means -3 gets a parentheses. And then +1 has a closed circle, so it gets a bracket. And the other way we would write that is -3, okay, their x in the middle, and then 1. So we need our x values, right? Any x value on this line, we can choose it as long as it is between 1 and -3. So x values need to be less than or equal to 1, but x values also need to be greater than or equal to -3. Range, so smallest to largest, lowest down it goes. Okay, so the smallest number on my y-axis where I'll have a point on that line is down here at -2. And then the highest up, I have a point on my y-axis. I don't have anything up here at 4 or 3, but I do have a point down here at 2. So this would be the highest it goes up, or that I have a point, okay? But that point is a open circle, which means my range goes from -2, the bracket, to 2 with an open circle. And we can also rewrite that one from -2 to 2, but since this is range, we're using y. So we need, on our y-axis, we need our y values to be less than or equal to 2, or those y values need to be, y needs to be greater than or equal to -2. Okay, so if you'll notice in this example, this is actually a parabola. Okay, so this is our quadratic function. So we're going to talk about the domain and range for this quadratic function. Okay, so we're going to do our domain first. So we're going to look at our x-axis, right? So if I look at my x-axis and I see the furthest place my function goes to the left, okay? Well, here's the furthest that it goes to the left, about a -1. But if you notice, the furthest it goes to the left has an arrow. Well, you know what that arrow means? It means it keeps going on and on and on forever to infinity, okay? So this arrow is not only going to keep going up forever, it's also going to keep slightly going to the left forever, okay? Which means I could pick a point over here. If I picked a -4, eventually this parabola is going to have a point somewhere way up here with -4 as the x value. It's going to keep going to infinity though, okay? Which means I could choose a number -2 million on my x value, or on my x-axis, and eventually that parabola is going to have a point where the x value is -2 million, okay? So when your arrow, or when you end on an arrow, that arrow means you're going to infinity or to -infinity, Okay, so that's what that means for us. So our limit is not -1 because we have that arrow. Our limit is actually that it's going to keep going all the way to -infinity. Okay? It just keeps going. Then on the right side, the furthest or the largest x value that I see is over here, a little more than 4, okay? But right there where it reaches its limit on that right side, or where it stops on the right side, you stop at an arrow, which means this is also going to continue up, and this one's going to go to the right forever, okay? So since we ended on an arrow over here, our limit was an arrow, that means it doesn't stop, it keeps going to infinity. So your domain ranges from -infinity to +infinity. And if you remember, the infinity, you can never actually reach infinity because it just keeps going and going and going forever. So we give those parentheses. Okay? And then the other way you would write this is -infinity is less than or equal to x, since this is domain, which is less than or equal to infinity. X has to be less than infinity, and x has to be greater than or equal to, oh, and I made a mistake. Sorry, guys. These are parentheses, not brackets. So our domain goes from -infinity less than x, which is less than infinity. You can't equal infinity. I don't know why I put those or equal to signs underneath there. Sorry about that, guys. So -infinity is less than x, which is less than infinity. X has to be less than infinity, and x has to be greater than -infinity. It cannot equal infinity, okay? So don't do what I did and put the equal to signs underneath. All right, so range. We're going to go from the smallest value on my y-axis to the largest value on my y-axis. So the smallest, or the furthest down, I have a point, would be right here, and that is at -2 on my y-axis. Okay, so that's going to be my smallest value. And then the highest up it goes is about right here where it stops, but that's at 3. And then at 3, we have arrows. Okay, because this function is going to keep going up forever and ever and ever, which means it's going to keep going all the way up to infinity. Okay, so my range, my y values, this function has points that use the y values -2 and all the way up to infinity. It touches at -2, so we give it a bracket. So we go from -2 all the way up to infinity with a parentheses, which means we run from -2 to infinity with my y in the middle. You can't touch infinity, so y has to be less than infinity. But we have our bracket, we can touch -2, so y needs to be greater than or equal to -2. So we have -2 is less than or equal to y, which is less than infinity. Next example, we have a straight line, which means this is a linear function. Okay, so we're going to look at domain and range for linear functions. Okay, the cool thing about domain and range for linear functions is that they are always the same. Which reminds me, for quadratic functions, okay, I'll label this quadratic. Quadratic functions, your domain is always the same. Your domain will always go from -infinity to +infinity because you're always going to have that U shape. Doesn't matter where you shift that U, okay? It's always going to be going up and to the right and left forever. So your domain will always, or it's not going to always go up. It's always going to go right and left forever. You could also flip that parabola upside down, and then it's going to go down and right and left forever. So your domain will never change. The range for the quadratic will change. Your domain and range for the linear function will never change. It will always be the same. No matter where you shift that line, whether it's going up, down, horizontally, vertically, doesn't matter. Okay, so let's look. Domain, start by looking at our x-axis. So the furthest to the left that this function goes is, we'll say it's right here at -4. Okay, at -4, it ends on an arrow, which means it doesn't actually stop at -4. It keeps going all the way to -infinity. Okay, so that's gonna be my smallest. And then the largest I'll go to stops right here, okay? About 3.5 maybe, but it stops at an arrow, which means it doesn't actually stop. It's gonna keep going to infinity. So that will always be your domain for linear. -infinity is less than x, which is less than infinity. And then your range, looking at our y-axis, the lowest point on my function, okay, the smallest value, the arrow stops at about -1.5-ish, okay? But it stops on an arrow, which means it doesn't actually stop. It keeps going. It's gonna go down and down and down, all the way down to, you guessed it, -infinity. Okay, and then up above, the highest that we have a point on this function, the highest y value used for this function, stops at 3, but it stops on an arrow, okay? Which means it doesn't actually stop at 3, it keeps going up and up forever to infinity. So for linear functions, your domain and range are actually the same. Okay, they both run from -infinity to +infinity, and that will never change. The only thing that's different is when we write it, we put a y in the middle instead of an x, because this is range. Alright, now we're going to list the domain and range from this graph below. Okay, we have another function. This is our square root function. Okay, square root function, let's take a look. So our domain, the smallest value that it goes on my x-axis, smallest to the left, would be at 1. Okay, that's the furthest to the left. It's going to go on my x-axis. That's our limit on our x-axis. And then on the right side, it goes to about 4, but once again, we're ending on arrows, which means we're not actually stopping at 4. We keep going all the way to infinity. Okay, so my 1, it actually has a point at 1 on the x-axis. So we do a bracket for 1, and then it keeps going all the way to infinity with a parentheses. So my domain would be 1 is less than or equal to x, which is less than infinity. And then for our range, the furthest down, or the smallest value I would have on my y-axis, okay, would be right here. Here's my y. So the furthest down it goes is at +2. And then it highest up it goes, gets to about 4 and stops on an arrow, which means it doesn't actually stop. It's gonna keep going, right, all the way up to infinity. So my range is 2 to infinity, or 2 is less than or equal to y, which is less than infinity. All right, so next example. Listed at, all right, so absolute value, we have that V shape, okay? So for domain, x-axis, we're gonna start by looking at the furthest to the left. We're gonna have an x value, okay? If you go to the furthest that this function goes to the left, you're ending at an arrow. We already know what that means. If you end on an arrow, you're not actually ending. It's going to keep going and going and going. So it's going to keep going all the way to negative infinity. And then same thing when we go to the right side. The furthest to the right this function goes, or where it stops at, is an arrow, which means it doesn't stop. It keeps going and going and going all the way to infinity. So absolute values always have this same domain, negative infinity to infinity, okay? Doesn't matter whether your absolute value is going up or whether it's been reflected across the x-axis and it's now flipped down. The v part is always going to go right and left to negative and positive infinity, okay? Your range, however, will change. It will not always be the same for every function. It depends on where your vertex is, okay? Because that's either going to be your minimum if it's low or your maximum if it's up high, okay? So in this case, this point is our highest point, okay? So this would be our maximum, right? So let's look. We're going to start, we always go smallest to largest, so we're going to start going from our smallest that our function goes. The lowest down it goes is to -3, but at -3 we have arrows, which means we don't stop. We keep going all the way down and down forever. So from negative infinity, and then the function goes up, and it does have a stopping point. It stops here at 2. The highest this goes, would have a y value of 2, okay? So our range would go from negative infinity up to 2, okay? And then once again, we can always write these the other way as well. So negative infinity is less than y, which is less than or equal to 2. Our domain, looking at our x-axis, the furthest to the left this function goes is at this endpoint actually, which is at -2. And the largest value we're going to have on our x-axis, or the largest value our function will have, largest x value, would be right here at 3. So as long as I pick a value between -2 and 3, there will be a point on that function with that as its x value, okay? So -2 has a closed circle, so it gets a bracket, and then 3 has an open circle, so it's getting that parentheses. And then we can also write it, so -2 is less than or equal to x, which is less than 3. And then we can look at our range, our y-axis. So y goes up and down, so the furthest down we have a point on that function would be right here at -2. And then the highest up is not actually our endpoint, okay? Our endpoint is at 1 on my y-axis, but we still have points in our function greater than 1, okay? We actually have points that go up to 2. Oops. So right here we have a point that's at 2 on my y-axis. So that is the highest value, right? The highest number that we would have a y value, or the highest y value we'd have in our function, okay? So this would be at +2. So our range goes from -2, open circle, all the way up to 2, the bracket for this one. Or -2 is less than y, which is less than or equal to +2.